All right, all right, all right. So today we're doing problem 2364, count number of bad pairs. This is definitely one of those problems where the condition seems kind of complicated, but if you just take the opportunity to modify it slightly and look at it from a different perspective, you'll notice that the solution is pretty straightforward, right? So there's many Leetcode problems that kind of fit that mold, right? Where you're given this condition that seems complicated, but if you realize, well, if I just massage this a little bit, right? If I just change some things around, right? Not doing anything illegal or that is illogical, but logically make some modifications, the problem becomes much easier to solve. Okay. So with that said, let's go ahead and get right into it. So very short description. We love those. So you're given a zero index integer array nums. A pair of indices I and j is a bad pair if I is less than j and j minus I isn't equal to nums of j minus nums of I. Okay, so let's just write that down because it seems like it's important, right? So we have a bad pair if j minus I is not equal to nums of j minus nums of I. Minus nums of I. Okay. Now we want to return the total number of bad pairs in nums. Okay, so in this example, change the color up a little bit here. For example, 4133. Well, what's going on here? Well, how many bad pairs are there? Well, it turns out there's 5. I'm not going to go through all of them, right? But, 0, 1 is a bad pair because if 1 minus 0 not equal 1 minus 4, how do you get those calculations? So this is the 1th index, the j index, minus the 0 index, not equal 1 minus 4. That's not true, right? And you can go down through this whole thing. Not going to do it, but I think you kind of understand the logic of this problem, right? It's pretty simple, right? You just want to find all the pairs where this situation is true, right? So for 4 and 1, I said I wouldn't do it. Now I'm going to do it just to be, this is I and this is j, right? So I is 0 and j is 1. So we say 1 minus 0 not equal to nums of j. What's nums of j? 1 minus what's nums of I? 4. This is negative 3. This is 1. They are not equal to each other, right? So that would add 1 to the solution. So there's a lot like negative here. Like if it's not equal, then it is meeting the condition. So then you do add 1 to the solution. Okay, and that happens 5 times, right? So the easiest way to solve this, right, would be to just literally iterate through all ij pairs, right? But it's going to give you a timeout because that would be an n squared solution. And let's just write it for the sake of writing it, right? So if you say, okay, res equals 0, res beating the solution, and at the end we'll return res, okay? And then we'll just look at all I in range 0 the length of nums. You don't need to put 0 here. Right now, I has to be less than j so that it pretty easily leads you to think, okay, for j in range, well, it has to be greater than I, length of nums. And we'll say, okay, we'll literally just put the condition in here. If j minus I not equal nums of j minus nums of I, well, res plus equal 1. We run that, it's going to say it's good, but then when we actually submit it to the solution, it's going to say timeout limit exceeded. Why? Well, because this process here takes, right, O of n time, the outside loop, and the inside loop, although it's based on I, it's still proportional to O of n time. So this solution is O of n squared, right? And O of n squared isn't going to work for 10 to the 5, right? Because generally Leetcode solutions should be around 10 to the 6. So if n was proportional, the worst case 10 to the 5, that would mean n squared is 10 to the 10. That's far exceeding, our kind of rough limit of x times 10 to the, 6, something like that, 10 to the 6. So it's not going to work, right? It's too slow. I mean, it works, but it's just far too slow. So we need to think about kind of a more intelligent way to solve this because this brute force approach of just looking at every pair is far too slow. Okay, so in order to do that, let's start thinking about how we can take this problem and try to put it in a position where it's just a little bit, I guess, easier to deal with these pairs, right? Because what I want is, ideally what I would do linearly here, right, is I'd look at each number I look at each number and say, who doesn't match with 3, right? So I would basically, what I'm basically saying here is, ideally, if I wanted to do this linearly, there would need to be a way to say, okay, let's say this 3 was my j, right? So I'd only look at things before me because I has to be less than j. I want to say how many i's. Now, when I say i's, I'm saying how many ith items, right? How many I index items don't, it's so hard with all these negatives. How many I items in this pair have it such that j minus I not equal nums of j minus nums of I? Right, so what I'm basically saying here is, you can't really see the whole thing, but you know the formula, right? It's up here. But the idea is like, I look at a j item, right? And I say, okay, how many people before me meet this condition so I can add, right? That's how you would do it linearly. So we have to find some way to say, okay, look at this element. How many before me don't meet this condition, right? Now, if there was no j minus I, right? If this problem was instead just nums of j not equal nums of I, how would you solve it? Okay, the easiest way to solve it would be with a hash list, right? You'd go through this solution. If this, I'm just saying hypothetically, right? The idea I'm trying to get across here is, hypothetically, if this problem was slightly different, how would you solve it, right? And then we'll use that information to say, okay, how do we apply this to the larger problem here? Okay, if you wanted to literally just find out how many nums of j not equal nums of I, where I is less than j, right? Let's keep that condition because that condition is important. Okay. Well, I would just look at j and say, okay, how many elements don't equal 3? Right? That's all I'm doing here. Say, how many elements don't equal 3? How many elements don't equal 3 here? Right? When I start here, how many elements don't equal 1? So I should probably keep track of what I've seen so far to say, okay, how many don't equal? Well, what have I seen so far? So as I track through this, right, I keep track of what I see. I see, okay, here I see a 4, and there's 1 of them. Then I move over to the 1. I say, okay, now I see 1, and there's 1 of them. Right? And then I could say here, I could say, okay, how many elements don't equal 1 that I've seen? Well, totally I've seen 2. And how many of them don't equal 1? Well, how many 1s have I seen? 1, so that's 1. That doesn't make sense. Let's just go forward 1 more. So we look at 3, right? Let's say j is 3 here. How does this calculation work? Well, how many have I seen so far? Well, j equals 2, right? If we think about it in this terms, right? 0, 1, 2. So that means I've seen 2 items. I've seen j items. Keep it general. Right? If I'm on this second index, right? If I'm here looking at j equals 2, that just so happens to mean that I've already looked at 2 things. So that means that there's 2 i's that there could be, right? So there's 2 possible i's. Right? So there's 2 things before me that could not equal. So the total number is j that could be, but how many of them equal me? Well, how many times have I seen, we'll call this thing seen, j minus seen of nums of j. Okay. And we'll write that again to make it a little bit more clear. So if I keep track of everything that I've seen so far, right? Now, I'll make this a little bit more clear by annotating here. So this term here is what? This term is all the j's before me. I mean, all the i's before me. And this is, of all the i's before me, I only want to account for the ones that don't equal me, right? So I get all the, it's like reversed. I get all the i's that are before me, and the only ones that I'm going to account for that aren't equal to me, well, I want to subtract the ones that are equal to me because it doesn't meet the condition, right? So this is all of the i's before me. This is all the i's before me that equal me. right? And if this concept doesn't make sense, what I'm basically saying is, if you're in a room of people, right, and you're all talking about your age, okay? Well, there's a total number of people, right? I always like to do it like this, right? There's a total number of people, and there's the people that are people with the same age and people with not the same age. Does that make sense? Right? If there's a room of people, right? There's the people that have your same age. If you're 22, right? And all the people in the room, there's people that are also 22 and there are people that aren't 22. And if you add them all together, it's all the people, right? They're either 22 or they're not 22. So you add them all together, you get all the people. So if you want to figure out all the people that don't have the same age as you, we'll just take all the people, right? Total number of people, and subtract out the people that have the same age. And that's equivalent to the number of people that don't have the same age as you, right? Right, there's 100 people in the room. You're 22. And there's 2 other people with the same age. Well, then there's just 100 minus yourself, minus those 2 people, 97 other people that don't have the same age. Okay, so that's literally just the same concept here, right? The concept here is if I'm trying to find all of the elements that aren't equal to each other, the pairs, well, it's just all the pairs that could possibly exist minus all the pairs that are the same. So as long as I count through this thing and I keep track of all the items before me and how often they occur, I can say, okay, as I track through, I'm like, okay, this is my new j value. Everything before are all the possible i's that's equal to j. I just subtract out all the people that are the same. Okay. So how does that help us with this problem? Well, the thing is that this j minus I nums I thing, well, it's really just the same thing. Okay. So I'm going to write it again. Nums of j minus nums of I. All right, and you guys say, well, this is very different. This isn't nums of j not equal nums of I. Now there's this other factor of where the person is. Well, what I'm going to do is I'm going to add I to both sides. Plus I not equal okay. And then I'm going to I don't want to add I to both sides. I apologize. I want to, let's subtract j from both sides first. I mean, you can do it either way, but j minus I minus j. So I'm subtracting j from both sides. Okay, now you'll notice that these 2 j's cancel out. Now I'm going to add nums of I to both sides, right? These are all legal arithmetic operations. I'm not doing anything crazy here. So I'm going to add nums of I minus I equals nums of j minus nums of I minus j. Ugh, so annoying. Basically, when I add nums of I to both sides, right, you're going to get rid of this term. So you're going to end up having in the end here nums of I minus I. These are not equals. Not equal nums of j minus j. So why did I do all this work to get around, right? Like, you can walk through this arithmetic. I kind of messed up writing it out. But, right, I can move terms around and I get nums of I minus I not equal nums of j minus j. So why did I do it like this? Well, if you have your original array, right, all you have to do is generate a new array by subtracting out these things. Right? So if I say that nums hashtag equals all the same things, but I subtract out the indexes, right? So if I say nums like hyphen of I equals nums of I minus I, well, then that just means that nums of I in the condition not equal nums hyphen of j. So basically what I'm saying is if I set this little solution by making a little additional condition, well then nums of I not equal nums of j, the hyphen's there, right? And then we have the same condition. So then this would just be, the same condition here, but it'd be nums hyphen of j. And we can walk through the solution like that. So I'm going to write it out, and then if it doesn't make sense, maybe we'll come back. But that's generally the idea to this problem, right? So now we will look at each j. So we go. We need to keep track of what we've seen. So we'll make a default dig for that. We start at 0 now. And then we basically say, okay, how many conditions meet this? Well, how many have we seen before? So we say res plus equal, j is the number that we've seen before, minus how many times have we seen the current element that we're looking at? Well, the current number we're looking at is nums of j, but remember that we need to subtract out the index, right? So literally just looking at this again, this is nums hyphen of j, which is equivalent to nums of j minus j. Okay. Because basically what I'm doing is I want to make it the condition where it's not equal to things before, but since we have that index thing, it gets a little bit more complicated. So what we'll do is we'll just move in, right? We'll literally just move in the condition by doing this math to move things around, and it just adds that extra term. Okay. Oh, and then at the end, right, we have to add that we've seen this element. What's the element we've seen? Well, you might feel inclined to say this, right? But we're comparing it to nums hyphen of j. So that'd be nums of j minus j. Okay, now if this part doesn't make sense to you, all I'm basically saying is by moving the conditions around, you can say, okay, these are two single array. This is the same array, just with the indexes subtracted out of everything. So an easier way you could do this if this doesn't make sense is you say nums equals, the element in nums minus I for index element in enumerate nums, right? So this enumerate function will subtract everything from nums, and then you don't need this additional term. Okay, so we'll do it like that first. And then it's wrong. How is it wrong? Oh, because I didn't even... nums of j plus equal 1. Right, because I'm trying to keep account of how many times I've seen everything. Okay, but I don't like this approach that much. It's just to show you that it can be done either way. All right? Or you can just, in place, account for the fact that it's different. Right, it's the same problem. All right, so what is the runtime and space complexity of this? Okay, so time is O of n, right? So we create this array, we create this hash map dictionary, and then we just look at each element, right? So we look at all n elements. We do a single operation, a single operation. This is amortized constant time operation. So that's O of n. For space, well, we have to create this thing to keep track of everything that we've seen. If all the elements are unique, then this thing will be populated with every single element. So in the worst case, it's O of n as well. All right, guys, not my best video. It's been a while since I made one, but I'm glad to be back. All right, later, players.